Alright, with day 2 of the inverse trig functions, we'll start to talk about taking the derivative of them. But first of all, let's talk about writing the expression in algebraic form. And so we're going to use the right triangle again. And so what I'm going to do is draw my right triangle. I'm going to go ahead and put theta in here. And I'm talking about this portion right here. I know that I'm really trying to figure out where is the tangent equal to 4x. That'd be 4x over 1. So I know that tangent is really opposite over adjacent. So I've got 4x over here, opposite over adjacent. What I'm really trying to do then is find the secant of theta. Secant is 1 over cosine. And so I'm really talking about 1 over the adjacent over the hypotenuse. The adjacent side's 1, but I don't know the hypotenuse. So I'm going to go ahead and figure out the hypotenuse using Pythagorean theorem. 1 squared plus 4x squared equals my hypotenuse squared. So that means I get 1 plus, this would be 16x squared, and then I'll square root both sides. I get the square root of 1 plus 16x squared. So this becomes 1 over, the adjacent is 1, and the hypotenuse I just found to be 1 plus 16x squared. So I have 1 over the square root of 1 plus 16x squared. When I take 1 divided by that, I end up with my answer of 1 plus 16x squared, the square root of it. Going on, we're going to do another one of those. So I've got a triangle. Here's my theta. This time I'm working with arc sine is x minus 1. So where is the sine of theta equal to x minus 1? So that would be opposite over hypotenuse. So opposite over hypotenuse. Opposite, x minus 1, hypotenuse is 1. So I'll say x minus 1, one of my legs, I'll call this part y. So plus y squared equals my hypotenuse squared. So I've got y squared equals 1 minus x minus 1 squared. And so then I could go ahead and figure out what that is. I could simplify this if you wanted to. We could say this is 1 minus, this would be x squared minus 2x plus 1. And then I would really have just simply, when you distribute this through, the 1's cancel. I'd have a negative x squared plus 2x. Or I could just simply say this is the square root of 2x minus x squared. So I just flip-flop those around. Coming back up here, then I have the secant of theta. Okay, the secant of theta would equal 1 over the cosine of theta. 1 over the cosine is 1 over, or is adjacent over hypotenuse. So if I look at my picture, adjacent would be the y. Well, y we found out to be square root of 2x minus x squared. So I'd have 1 over the square root of 2x minus x squared all over my hypotenuse of 1. And so when I would divide those out, I would end up getting 1 over the square root of 2x minus x squared as my final answer. Alright, in this problem we're going to solve for x. And so what I'm going to do is I am going to get rid of this tangent inverse, because that's really what it means, by finding the tangent of both sides. So I'm going to tangent both sides, in other words. So I'm going to write the word tangent on both sides. of the tangent of negative 1. That makes these cross out, and so I get 2x minus 5 equals tangent negative 1. Then it's just a simple equation where we add 5 to both sides, and we'll divide by 2. And I'll leave it in this form. I'm going to do another one of those where I solve for x. This time I've got arc cosine and arc secant on both sides. So I want to get rid of one of those two. And the way I'll do this is I'll get rid of the arc cosine by cosining both sides, by putting the cosine on both sides. So that makes those fall out. So now I have x equals the cosine of arc secant x. Now this is where I'm going to have to use the triangles again to help me figure this part out. So I'm going to say this is theta, and I'm going to figure out, okay, well, secant's 1 over cosine. Cosine's adjacent over hypotenuse, so this is really hypotenuse over adjacent. So when I look at this theta, my adjacent would be x, or no, excuse me, my hypotenuse would be x, my adjacent would be 1, because this really says x over 1. That will allow me to then be able to change my cosine. So I really have cosine of theta. Cosine of theta is adjacent over hypotenuse. So when I look at this picture, my adjacent side is 1, my hypotenuse is x. So I just need to solve for x. So I'll cross multiply, so I get x squared equals 1. Square root both sides, I get plus or minus 1. The next part is the derivatives for arcs. So we have got 3 derivatives we're going to learn. We're going to learn the derivative of arc sine. That is u prime over the square root of 1 plus u squared. So that means whatever this is, we're going to put 1 over the square root of 1 minus that term squared. And then what we're going to do is we're going to take the derivative of that term. The same thing on each one of those. The difference between arc sine and arc cosine is just the simple negative. Arc tangent is 1 over 1 plus that term squared, and then we'll take the derivative of that term. Let's try a couple of those. We're going to find this derivative. So the way we're going to take this derivative again is it's arc sine's derivative is u prime over the square root of 1 minus u squared. That's what it said. So we'll write 1 over the square root of 1 minus this term squared. That's what this is, u squared. So this term squared times whatever the derivative of that is, which is 2t. So I could simplify this to be 2t over the square root of 1 minus t to the 4th. Let's try another one. This one has a product rule in it, so I will do product rule. So I'll have first times derivative of second. This is arc tangent. Arc tangent is 1 over 1 plus, let me write that up there for you so you remember what it said on the other side. It said 1 over, and it said u prime over 1 plus u squared. So you're going to put this term squared, and then you multiply by the derivative of that, which is 5, plus the second times the derivative of first, which would just be 2x. So to simplify this, I would have 5x squared over 1 plus 25x squared plus 2x arc tangent 5x. In case the last video the answer got cut off, this is how it did simplify and reduce. Moving on to our last example, we're going to find the derivative. We're going to do that. We are going to take the derivative of the ln. We know the derivative of ln is 1 over t squared plus 4. And we have to take the derivative of that term, which would be times 2t. minus. Now we have the arctangent again. And this is just a constant up front, so I'll put the 1/2, and then I'll multiply by its derivative. So the derivative of arctangent, this is 1/2 t, so that's my u statement, this is my u, is equal to the derivative, remember we're going to convert it into, let me rewrite this. Let's put u here. Let's put u here, and then let's write what u is underneath here. U is that 1/2 t, this part right here. So this derivative would be 1 over, or u prime over 1 plus u squared. So let's take the derivative of that, which you end up getting 1 over 1 plus, remember this is my u, so it's 1/2 t squared, then times, you have to take the derivative of that u, which is 1/2. So what I'm going to be able to do is simplify this to be 2t over t squared plus 4 minus, I end up getting 1/2 times 1/2, which is 1/4, and then I'd have 1 plus 1/4 t squared. Now we actually can take this a bit further, and I will since I have some time. I'll say that this is 4, and then that ends up being t squared. So now I actually have common denominators for this problem. And a lot of times we'll stop ahead of time, but I knew this was going to happen, so we'll go ahead and finish this. We can then combine them and just say it's 2t minus 1 all over t squared plus 4.